All right, just a quick review of Chapter 5, Constraint Management. Hitting some of the highlights there, some things you should know. First of all, the theory of constraints. It's a principle to use in dealing with limits, and in the real world, things aren't infinite, and this is how we're going to make a process that has constraints function optimally in an organization. The first thing is to focus on the flow and not on the capacity. And this comes back to our process management. I use the analogy of thinking about a drive-through, where basically you want to get people through the drive-through continually flowing. You don't want to have these big stops. And that's led to a lot of the changes in drive-throughs that have happened, where there's dual ordering windows now and separate payment and collection window and things like that. It's all about balancing flow. So next one is every resource being maximized may not maximize throughput of the entire system. That's talking about something that can be very efficiently done may mean idle time somewhere else. It may not be worth optimizing. Going back to fast food, you walk into a McDonald's these days and you might see, as I did maybe a month ago, there was a cashier that was continually pushing people through the ordering process, but the orders were not coming out fast enough. So what ended up happening was there was a large number of people just sitting and waiting. And that time might have been better spent if some more effort was put into making the food, for instance, right? So that's a situation where taking an order every minute would have been possibly sufficient to be optimal. But the cashier was so optimized that it just didn't increase the entire system. Then the other one is that if you lose a time in a constrained resource, which is the bottleneck, then the whole system loses. That's a good rule, but it's important to note that saving an hour on a non-bottleneck resource or process doesn't make it more efficient. If you save an hour, in this case here, for instance, they saved time at McDonald's in the ordering process, but it didn't make the throughput of the system better. Ties into number 2 there. Theory of constraints again is that we only need inventory in front of bottlenecks and in front of assembly and shipping point. What that point is getting at is the need not to have inventory at other places more so than where it is needed. It's that inventory in other places is wasteful. So it's holding costs that don't need to be incurred. Whereas in front of the bottleneck, the holding cost being incurred is possibly of benefit. So work should be released into the system only as frequently as needed by the bottlenecks. And this comes back to the holding costs again. So constraints say, that you really can't put anything through the system faster than the bottlenecks. So only release work into the system as frequently as the bottlenecks can take work. Then we come down to, again, activating a non-bottleneck is not the same as utilizing a bottleneck. So again, this is back to the McDonald's ordering system. The cashier being active is not the same as utilizing a bottleneck resource. It just doesn't make the throughput higher, and it doesn't get better performance, so on and so forth. And lastly, which I think is probably the most important one, is capital investments should be viewed from the flow perspective, the overall flow, and the expense perspective. So operating expense, value generation. When you're going to put an investment into a process or manufacturing process or service process, you need to think about how the entire system is impacted, not just the one resource. So it might be great to spend money and put in 10 cashiers at McDonald's, but that's kind of wasteful if they can't make the food fast enough. All right, and now one of the mechanisms for resolution, I guess, of constraints after you've identified them is the drum buffer rope system. How that works is that your constrained process is your drum. So it is the beat. If you've ever rode in a dragon race, they have the drummer that sets the beat. That is, everybody moves to that beat. That's what we're talking about. So identification of the drum is basically the constrained resource or the bottleneck. Okay, so the buffer is going to go right before the drum, and it's an inventory time buffer. Essentially, it's just protecting flows so that process B can run at capacity all the time. The other buffer that's mentioned in theory of constraints is the shipping buffer. right before the shipping schedule. So in this case here, you will build up some inventory to prevent a loss of income from not being able to meet the market demand. I'd like to just say that I think it's, you can see from the diagram, which is one in the book and in the slides, that the market demand is greater than the process capacity of the bottleneck, the drum, which is 500 units a week. So that's something to also consider, that may not be capable of keeping up with market demand in the long term. In the short term, perhaps it can. And the rope, releasing materials to the drum beat. That's where I was saying that process A may not get materials released into it to run maybe 2 out of 3 weeks, but essentially it what ties the buffer back to the release schedule. Okay, so precedence diagram. This is something I've used quite frequently when you're doing a business analysis. You'll find a lot of processes, and people in the processes are only aware of what's immediately before them and what's immediately after them. So a person running a process in the service industry just knows where their input comes from and where their output has to go. They don't know or have a holistic view of the entire system. So what you would end up with is something like this, and this is a manufacturing one, where you have some work that's to be done, how long it takes, how long that work takes, and where it comes from, which is the predecessors. From this, then, what you can do is draw a diagram using this simple example, just like to say, too, that because the time is given, that there are 2 bottlenecks or constraints here, which is C, the attaching the axle, and D, which is attaching the agitator. And this is example 5.4 on page 188, because they take the longest time in that flow of processes.